So far, we have been looking at finding one unknown. So solving equations, linear equations, equations that would make a straight line if we were to visualize it. That's why we call it linear equations. And so far, we've only had one variable. So for example, we've worked with solving, let's say, 2x plus 7 equals 8x take away 9. The unknown is on both sides, but there's only one unknown, just the x. Now, we're in a situation where we have a pair of equations, two equations, and we also have two unknowns, x and y. It could be a and b, a and c, x, y and z, any two letters, but it's two unknowns, two equations. And we need to find both. So we know some number plus double another number is equal to 8. Or double the first number plus the second number, that's going to give me 7. What are the two numbers? And that could be a word problem. We'll explore word problems in a bit, don't worry. But let's just start off with, we're given the equations. We don't need to form the equations, we just need to solve it for two unknowns. Now, there's two different strategies we can use. The first one we will consider is what's called the elimination strategy. And look at this. Here's our situation. And the first thing you always want to do is to label up your equations. So step one, label your equations. Equation 1, x plus 2y is equal to 8. So some number plus double the other number. Another number is 8. And equation 2, double my first number plus my second number is 7. Equation 1 and equation 2. Now, you'll see that I have 2 times my first number, 2 times x in equation 2, but I only have 1x in equation 1. Now, the whole idea of this elimination strategy is that if you have the same number of x's, the same amount of each variable, then you can eliminate it by doing an addition or a subtraction. We'll stick with a strategy that allows us to eliminate using subtraction. That's what we'll try to stick with anyway. I might get all done with that at some point. So I've labeled my equations, and then the second thing I'll do, the next step I'm going to do is I'm going to multiply equation 1 by 2. Why do you think I'm doing that? Hint, hint. I want to get 2x. I've seen that there's 2 x's in the second equation. If I get 2 x's in the first equation, then I'll be able to cancel out. So I'm going to create this new equation, and multiplying the equation by 2 means that each term, the x has to be multiplied by 2, the 2y has to be multiplied by 2, the 8 also has to be multiplied by 2. That's what we mean by multiplying the equation by 2. Each term gets multiplied by the number we're multiplying by, in this case 2. So I have now 2x plus 2y. I double 2y. That will give me 4y. Doubling is multiplying by 2. And then 8 2's are 16. And I'll call this equation 3. So equation 3, 2x plus 4y equals 16. And just to make my life a little bit easier, I'm going to rewrite equation 2. So equation 2 is 2x plus y is equal to 7. That's our equation 2. Now that this is the case, now that I have the same number of x's, and I could have done it for y's, but I went with x's, I can subtract equation 2 from equation 3. So I'm going to do a subtraction. That's my next step here. I'm going to do equation 3, and I'll write down. It's always useful to write down what you're doing. I'm now going to write equation 3 take away equation 2. Just a short note, 3 take away 2. And I'll do my calculations. Now the 2x, take away the 2x. What was the whole point of doing this? We wanted to eliminate a variable. 2x take away 2x is nothing. 0, 0. So they're gone. I can ignore that. The 4y, and this is where you have to be really careful. You got to consider the sign in front of the other y. In front of the other y? Did that just happen? The tongue went, oh, okay. 4y minus and a plus make a minus. Is 4y take away y, and 4y take away y is 3y. So we have 0. Normally we don't write 0, so I won't write it. No x's anymore, but I'm left with 3 y's. I had 4 y's, and I've taken away 1. If this was a minus sign, minus and a minus would make a plus. So be careful. That might come up. So be careful with it. In this case, it's 3y, and then 16 take away 7. 16 take away 7 will give me y. So it would give me 9, not y, 9. So we now know, based on these two steps, well, three things we did. Let's just recap and we'll finish off the job. 3y is 9. What's y? Let's just write it down. That means when we move on that y is equal to 3. So we divide both sides by 3. If I divide by 3, I'll get y is equal to 3. I'll show you how we can use that to find x in a moment. But let's just recap what did we did. The first thing we labeled up our equations. And then we looked at, well, do I have the same number of x's anywhere or the same number of y's? Because if you do, then you just think, well, I'm going to do a subtraction or an addition to cancel, to eliminate the y's or eliminate the x's. In this case, we didn't have the same amount in each of the equations. So what we did, we multiplied, we doubled the first equation so that we'll have 2 x's in both equations. Once we have the same amount of x's in each equation or the same number of y's, we can cancel them out. We did the subtraction. That's what happened. Remember, it's video. You're thinking, oh, if you're feeling lost now or what have you, if that happens, I mean, I explained that very, very clearly and you understand it totally, don't you? That might be the case, but it's not the case for everybody, and I get that. But remember, the power of video means you can rewind, go over it again, make extra notes, way more than I have here, and then use your notes to help you move forward. You might want to write step 1. This is what I do. Step 2, this is what I do. So the stuff I'm saying, you might want to document it and then follow that. Yeah, that's part of the learning process. Now, y is equal to 3. If y is equal to 3, the last bit, how do I find x? We do this lovely thing called substitution. So what we're going to do, we're going to substitute y equals 3 in, and you can choose any equation you want, but this time I'll go with equation 1. So I'll go with equation 1. So I'm substituting y equals 3 in equation 1. In other words, where I see y, I replace it with this new value, 3. So in equation 1, I now have that x plus 2y, and remember 2y means 2 multiplied by y. I can represent that by putting the number in brackets, so 2 and then 3, and that is equal to 8. Now we have x plus 2 times 3 is 6. X plus 6 is equal to 8. So you're thinking some number plus 6 is 8. What's that number? And you can see the equations. Once you get through these eliminations and substitutions, you get linear equations that are super easy. Like the first set of linear equations you were solving when we were just practicing. No brackets, nothing. No complications. X plus 6 is 8. So x is equal to 8. Take away 6. X is equal to 2. And the last thing you will generally do, what do you think is the last thing you'll generally do? Check. Yeah. That's it. That's what you were talking about. Oh, I didn't want it in the same color. You're gonna check your answer. Remember, in the power of algebra, you don't just go out there, do a sum and move on with your life. You check. We'll see an equation. Let's check in equation 2 because we substituted in equation 1. So in equation 2, let's see if it works. We're saying x is 2, y is 3. So let's see. 2 times 2 plus 3. What's 2 2's? 4 plus 3, which is equal to 7. And it's cha-ching. Oh, yeah. That's what we're talking about. It works. It works. So feel good. You've checked. You know your answer is right. And obviously, and then the last bit, really, this is the last step. If in your formal exam context, we just want to tidy up things here a little bit, is that we would, I'm trying to get the right color here. You'll have your nice answer line, which I clearly don't have space for here. Oh, man, did that just happen? Yeah, that just happened. Damn, that wasn't supposed to happen, you know. Ooh, oh, man, right. Okay, don't worry about it. Don't worry about it. Just thinking about space, how I'm managing my space, because I've got to keep my pretty picture up in the top right corner. Oh, it's all good. It's all good. Yeah. You feeling good? You all right? I'm all right. You just write in x equals 2, y equals 3. You just want to make that clear. Okay, so that's how you do this. That's how you do this thing called simultaneous equations. That's how you go into your GCSE exam if you're doing GCSEs, UK GCSEs, and that's how you get 3 marks. One of these is going to be probably worth 3 marks on a foundation paper that That might early starter might reduce it to 2 marks on a higher paper if they put it there. There's some trickier ones or the word problems, which would more likely be on the higher paper. But you gotta learn the basics. Gotta, what do they say? You gotta creep before you walk, or you gotta walk before you run. That's how it works, yeah. And gotta practice to become perfect. So, hint, hint, hint. Time for you to practice. Yeah, go on, do. Did I really put another example? Now, E2, you do E2. You go on, you do E2. Yeah, I'm just gonna. I haven't rocked my. Let me rock my chair. Just release the lever, and I'm rocking my chair. You're doing the work. Thank you. Rocking my chair. I'm having a coffee. See, did I ever show you all this? I don't know if you can read it. It says teaching leaders, and I committed to this cause. Take a lead, make an impact, change lives. That's why people decide to get into teaching and to take on more responsibility. It's about taking a lead, make an impact, change lives, of better lives for everybody. Philosophical, sir. We're just doing maths. What's all of this philosophy? Hey, education is more than just doing questions and getting answers. Come on, you know that, I know that. Yeah, let's do this thing. Right, power to pause if you haven't already and you're listening to me. Stop, manage your distractions, use the power to pause, do the question, okay? Get the question sorted out. You have it sorted out, you power pause, you ready to go? Okay, now I got about 5 or 6 of these again, but I'll do this one. The rest of them probably just gonna do answers, but I'm gonna do this one. First thing, what's the first thing I do? I label up my equation. So I have equation 1, I have equation 2. Then I look and I see, do I have the same number of A's? No. Do I have the same number of C's? No. So I can't eliminate either variable, but what I can do is the second equation, equation 2, if I multiply that by yet again 2, it won't always be 2, but it's 2 again. If I multiply it by 2, then I'm going to end up with 2a, because what's going to happen? Multiplying the equation by 2, a is going to be multiplied by 2, the c is going to be multiplied by 2, the 8 is going to be multiplied by 2. All of them are going to be multiplied by 2. What do I get? I'm going to make my equation 3 now, and my equation 3 is 2a plus 6c is equal to 16. Can I just say you don't have to put equation 3 on top? I am going to put it in, then I'll put equation 1 below. So 2a plus 4c, which will give me 13. And that's what I got there. I now have my equation 3 and my equation 1. At this stage, can I just show one thing I forgot to show is, well, why does this work? Are you allowed to multiply throughout in an equation? Note, I said in an equation. If you do this with an expression, you're changing the expression. This only works with the equal sign. And the idea behind it is, look at this. If I say 2 plus 3 is equal to 5, I hope you agree with that, so the left-hand side is equal to the right-hand side. That's the idea of the equations. Then if I multiply by 2, what do I get? I get a different value. So 4 plus 6 is equal to 10. The values change. They're all doubled. But that principle that the left-hand side is equal to the right-hand side remains. This is what, and note what we were doing. We weren't changing the unknowns. We weren't changing A and C. All we were changing is the multiples. How many A's and how many C's on the left-hand side. That is why this principle works. And I just thought I'll show that out there. You can multiply. Once you multiply the left-hand side and the right-hand side, or divide the left-hand side and the right-hand side, each term, if you multiply each term or divide each term by the same value, you could be making your equation easier to solve without changing the value of the variables. But you must do same idea like fractions, like ratios, equivalence, the idea of equivalence. What you do to one, you do to all the rest, and it has to be multiplication or division. Okay, just thought I'll bring that idea across one more time, and then back. It's like, what just happened there? I lost my chain of thought. How do I finish this specific question? And actually, why did I take off that stuff? I leave that there. That's good, useful information. we got to subtract. We're going to do a subtraction. We labeled up, we identified we didn't have the same number of A's, so we multiply by 2 to get the same number of A's, and now we can take away all my A's. A's, you are gone. You will be eliminated. Eliminated. 2A take away 2A is no A. Zero. Zilch. We don't. A doesn't exist anymore. And we need to do that because you cannot find two variables at the same time. It's just not going to happen. Alright? Not going to happen. You find one, then you substitute one to find the other. That's the logic we're working with. Now got 6C, take away 4C, take away, so that's 2C. 2C, and then 16 take away 13, and 16 take away 13 is 3. So what we're looking at here is 2C is equal to 3. And you're thinking, what? I didn't sign up for this. That I can't divide 3 by 2. Hey, yeah, fraction. Get used to it. Fractions, decimals, it happens, okay? Not the whole world is not about whole numbers, all right? Getting scared because the numbers are, oh, come on. If 2C is equal to 3, then we're going to divide both sides by 2. That balancing idea I'm sticking with here. And then main C is equal to 3 on 2. Or if you want, 1.5, or if you want 1.5. Yeah, you can. Which is your favorite? Should I do a survey on this? Do you want to go at 3 on 2, 1.5, 1.5? You know what, to be honest, for me on this one, I'm thinking 1.5 is a nicer value to work with because we need to do a substitution, and substitution with the decimal is probably going to be easier. But be prepared, you can get decimals. It's not just going to be all nice and whole numbers. It doesn't work like that. We have the value of C. What do I do now? I substitute. I do sub C in. I'm going to substitute into equation 2. I looked at equation 1. I was like, hell no, I ain't going to do that. 2A, 4C, 13. No, that's hard work. Just substitute in 2. We will have to check with the numbers in 1, but yeah, we'll deal with that when we get there. let's deal with substitution in 2. And what I end up with now is that A is equal to 3 multiplied by 1.5 of substituted C. Should be C equals 1.5 and 2. And that will give me 8. What did I just write there? That C plus, thank you very much. No, A. Breathe, deep breath. A, so substitute in the equation 2, A plus 3C, A plus 3 multiplied by 1.5, the multiplication sign. If you put a number in brackets, it means the number outside is being multiplied by the number inside. The bracket is key to represent that using the bracket. You can't just put 3 point. You can't do this, can you? 3, well, that's 31.5. If I put in brackets, now it's multiplication. So you learned that. That's another way of representing multiplication, okay? Yeah, I'll leave that as well. Should have put it in a different color. Whoa. That's all that is beautiful learning, isn't it? Beautiful learning. Right, okay, so we have A plus 4 plus 4.5 is going to give us 8. And questions like this, I'll just let you know, it's one like this. If it's going to have decimals, then I would expect it to be on the non-calculator paper. That said, sorry, on the calculator paper. That said, these values are not difficult to work with. I have no issue with you using a calculator to do these at this stage, but do not think that it will always be on a calculator paper. Most likely, but you should be prepared to put in the work to do a calculation like this without a calculator. Don't just look at it and think, I can't do that, I can't do that, I can't do that. Let's be serious, yeah? Take your time. 3 times 1.5 is, if you're not comfortable with the multiplication of it, just add. Thank you very much. Ooh, got that off my chest. Right. A is going to be 8 take away 4.5, and 8 take away 4.5 is going to be 3.5. So we have A is equal to 3.5. I'll put a squiggly here with the two answers. What we're saying is that A equals 3.5 and C equals 1.5. That's the so much for now. The square looked better, didn't it? Let's do the square. The square looked a lot more professional. Yay. And should we remove the squiggly as well? Yeah, the squiggly, I'm not feeling it. Yeah, that's a bit better. I mean, the handwriting is a bit funny already, so yeah, that's a bit better. Um, am I done? Am I going to just walk away from this question? No, no, we don't do that. We don't do that. We don't walk away without checking. You got to check. Put the effort in. You worked hard. You got your answer. Check your answer. Got to make it happen. So, oh God, checking one. So we're gonna do checking one. I'll just put it up here because I'm cramped for space. So I'm gonna do the check in one. Check in equation substitution in equation one. That means I got 2. I'm gonna double the 3.5, and 3.5 and 3.5 is 7. It's not that painful to do. So that's 7. And then I'm going to add 4 times 1.5, and 1.5 and 1.5 is 3, double it is 6, so 4 times 1.5 is 6. So what we have is 7 plus 6, which is equal to 13. So it actually does work. We've made our check, and I think that says it all. Now, you did do this as a practice, and just in case you wanted a more, and remember, you can go over this or make your notes. When I say notes, very shorthand. You're writing step 1, step 2, step 3, and then then look out for. Make sure you don't. Make sure you don't. So just key ideas that you want to help you, that can help you when you're doing the question. That's a nice strategy. Making those notes, and now practice. Here's 3 of them. 3 bad boys. Three, yeah, 3 of them for you to work on. Pause, you work through these, please. Pause and you work through these. Thank you. Thank you very much. Okay, right. You've had your opportunity. You should have worked on them. I'm gonna put in the. Hopefully, I'll do these answers right. I'm gonna do C. I want to do C because it has that minus sign. How did he feel doing C? That's the one I'm interested in, because that's a bit different to what I was doing before. Anything else? No. C is the one I'm gonna do. But for A, what do I have here? You should have x equals 2, y equals 3, and let me just check that. 2. Oh, that is like not working. Right. Sorry, wrong answers. I'm looking at the wrong answers. Don't panic, don't panic. But you see what I did there? You see what I did there? I didn't just write down the answer. What did I do? I checked. As soon as I substituted those values in the first equation, equation 1, 2 plus, well, 3 2s is 6. 2 and 6 is not going to give me 5. So that's wrong. Checking is important. So it is going to be x is equal to 1, y is equal to 2. And that works. I'm happy at that. And then for B, I'm seeing x equals 5 and y is equal to, let me just bring, y is equal to 2. And let's just check if that works. 5 3s are 15, 15, and then 2 2s are 4, 15 and 4 is 19. I've done my check. I've worked out 3 multiplied by 5. Remember the bracket. The number has to be in the bracket to get the multiplication. Plus 2 multiplied by 2. 15 plus 4 is 19. Okay, 15 plus 4 is equal to 19. Let's do C. And I'm not going to do it fully. Well, yeah, okay, I am going to do it fully, but I'm thinking about my space. So everything I'm going to do, let me make a line, because I'm worried about running out of space, and the line should have been straight, but it's not straight, and I'm not going to try and fix it, because then the computer messed me. Technology. I am an expert. I'm just saying, right? Let's do C. We're going through C. For C, we have x take away 2y is equal to 4. We're going to multiply. I'll label it equation 1, equation 2, and I'm going to multiply equation 1 by 4 to get the 4x. So that's where I'm going to start here. So I have 4x take away 8y is equal to 4 4s is 16. Remember what's happening is each term is being multiplied by 4. Make sure you're doing that. And then, so that's equation 3. And then we're using equation 2, which was 4x plus 3y is equal to 49. I don't like that. That's going to get ugly, isn't it? So you know what I'm going to do? I'm going to rewrite this. Just hang on. Look at, and this is how important this is. You can change things around. And actually, no, I'm going to leave it because that's the way it would have happened on paper. And then you look, do I want to do 16 take away 49? No. So we're going to write the subtraction sum. This requires some thinking on your part, concentration. But look what I'm going to do. I'm going to say subtract. Actually, I don't even need to write the word subtract. What we're going to do is 2 take away 3. We're going to work backwards. You can do that. Make the question as easy as possible. So it's either you could put equation 2 on the top and then do the subtraction so you're clear on what you're doing. But I'm just going to write, I'm doing 2 take away 3. So 4x take away 4x. I'm going bottom number take away top number. And then I have 3, look at this, minus 8. The minus and the minus makes a plus. 3 minus 8. Minus 8 is a plus of 3 and 8, which is 11y. Did you have the 11y? Well, you might have done this differently, but that's what I'm getting. And I'm just thinking if you went the other way, it would have been harder. You'll get negative numbers. Ooh. And then we have 49 take away 16. 49 take away 10 is going to give me 39. And then if I take away 6, it will give me 33. Do you do your subtraction like that? Ever did that? Take away the 10s first? Your brain works like this sometimes. I looked at that and I was like, hey, that take away, go back 10, 39, then go back 6, 33. Y, 11y is equal to 33. We're going to divide both sides by 11. You see how that goes. And we get that y is equal to 3. And then we substitute y equals 3 in equation 1. So I have x take away 2 times 3 equals 4. We're going to get a negative number. X is equal to, what am I saying? We're not going to get a negative number. We're going to get 10. The minus on the left-hand side, change side, change sign. Woo! So x take away 6 is equal to 4. X is equal to 4 plus 6. Just to be clear, where am I getting that 6? I did 2 multiplied by 3. And I'm getting x is equal to 10. So your answer for this question, let's put x equals first. And let me just check if I did it right. 10, 3, yeah. X equals 10. Y equals 3. That's the answer you should have had for this one. And I should put it in red. X equals 10. Y equals 3. That is a 10. 10. Right. And we can check it out. Let's check it in the second equation that we didn't do. I'm not writing my check, but write your check. Make sure you do your check. 4 times 10, I'm doing what I actually am writing it down a bit. 4 times 10 is 40, plus 3 times 3. 3 times 3 is 9. 40 and 9 is 49. So we're right, 10 and 3. Those are the values that you're looking for. Whew. We need to do more. Let's continue. Well, we just did 3 questions. Come on, 2 more. And there's more. There's more to come. Off you go. Off you go. See how you get on with these. Got the negative signs to work with, but I hope from the other example I did, you get the idea and you can manage these. They're plus signs in the middle, so all of these should be subtraction problems. And let's see. You use the power of the what? Did you forget to pause? You forgot to pause and do them. Oh no! You forgot to pause and do them. Oh no! Pause and do the questions if you haven't done the questions already. I thought you would be in the routine now, but and listen, sorry. Oh, it was on the other page. Sorry, I didn't realize. It's all there. It's all done. It's all done now. You use the power of the pause. You tried your absolute best. I'll put the answers for you to mark your work. That's cool. We're cool. We're cool. We're cool. You, me. We're cool. I got the orientation wrong. What's happening? What's that? Did y'all see that? What's that? What's that funny cursor thing? What's that? I never see that before. Okay, it's back to normal. It's all good. It's back to normal. It's all good. What do I want to do? I want to put the answers, yeah? We got for this one, we'll check, but I believe is X. You see, I changed it. I didn't put question numbers and all of that. I should have put A and B. Did you put A and B? Yeah. So I'm looking at the answers. Let me actually no. You know what? I was gonna show you the answer list I pulled because I pull out special questions for you. But then I realized I can't do that because I'll show you the answers for the other questions. I'll show you at the end maybe. X equals 5 and then y equals minus 2. That's what I think the answer to this one is. Let's check. Let's check. We will do 4. Is that what you got? You smiling? You feeling good? Brilliant. I gotta make sure it's what you're supposed to get. 4 times 5 plus, actually, no. Let's do the negative sign one. No, I don't want to do it. You did it. I don't want to do that. Y is equal to, and then 2 times minus 2. 2 times minus 2. And what you get there is 20, and then 2 times minus 2 is minus 4. 20 take away 4 is what we have, so 60, and it does work. That's the answer there. And then for B, I'm reading x is equal to minus 2 and y is equal to 12. X is equal to minus 2, y is equal to 12. And we will do that check again. We'll have 5 times minus 2 plus 12. And 5 times minus 2 is minus 10 plus 12 minus 10 plus 12. So that gives us 2. So that's a correct answer. X equals minus 2, y equals 12. Those are the 2 answers you should have. Next, here's 2 more for you to do. You know, and I'll flag up this one part. Okay, we'll call this C and D. We'll just call it C and D. Although I called it problem 3. No, 3A and B. That makes no sense. Whoa. 3A and 3B. 3B is an actual exam question. We're at 3 marks, and actually does have a slight difference to everything else we've done. Let me see if you spot that. I'll do 3 as well. That's an actual GCSE question worth 3 marks. That one there. Right. Okay. Right. It comes from actually. Let's do referencing at Excel. It's from our Edexcel. That was on an Edexcel 2017 paper. So written down referencing. Yeah, referencing. Right, okay. A and B, if you want to try those, please. You're doing A, you're doing B. Right, pause, you work through, and now I need to present the answer, and I believe you should have x equals 5, y is equal to 6, and we'll try 7 times 5, take away 2 times 6. Does it work? 7 5s there. 35, take away 6 2 is 12, 35 take away 12. You're getting 23. Yay, it works. Now let's do part B. And for part B, I'll give myself maximum space. So I'm going to put a line, and you will notice how I have improved. And that line is straight first time. First go, that line is straight. Whoa, let's just leave the straight line. Let's not try to move it up or anything like that. And actually, do I really need the extra space? No. Did you realize what happens with that question? What was the first step? We label our equations. So let's just go through the process here. Label, I got equation 1, I got equation 2. And then we're thinking, do I have the same number of x's? Well, stop. Whoa, hang on. They actually gave us the same number of x's on an actual GCSE question for 3 marks. Really? Seriously? Yeah, they did it. I mean, what they've made the challenge here is having those negative signs. Ooh, dealing with negative numbers is a bigger assessment here in many ways. So we can just get into the subtraction. There's no need for that multiplication step in this particular question. I just have 3x take away 3x, and 3x take away 3x is nothing. And then y, and this is where you have to be careful. A minus and a minus makes a plus. So y minus 4y is y plus 4y, giving you 5y. And then minus 4 minus 6. Now we have to work out minus 4 minus 6, and that's going down on the number line. It's not negative and a negative making a positive, which a lot of people do. You don't. You're thinking, anytime you're thinking addition and subtraction on the number line, what you're thinking about, addition and subtraction with negative numbers, or at least one negative number involved, you're thinking about adding and subtracting on a number line. And in this particular case, that will give me minus 10. So minus 4 minus 6 is minus 10. So y, 5y is minus 10. If we divide both sides, change color. Come on, teacher. If I divide both sides by 5, divide by 5, I'm going to get that y is equal to minus 2. So y is equal to minus 2. We can now substitute the y equals minus 2. I can do it. Helps if I write a bit nicer. So we're going to we're going to do the substitution here. And what is that going to equal to? Where am I? What am I doing? We're going to substitute y equals minus 2 in equation 1. It's easier to work with. And that means we get 3x take away 2. Y is minus 2 plus minus 2 is minus 2. 3x take away 2 is equal to minus 4, which means that 3x is going to be minus 4 plus 2. Ah, is that right? Now it's getting a bit interesting. Ooh, because we're going to get some fraction thing, but it's no big deal. We have 3x is equal to minus 4 plus 2. Minus 4 plus 2 is going to give you minus 2. And I need to continue on this side. I knew I was going to run out of space. So what we're ending up with is 3x is equal to minus 2. I'm just going to simplify. And then that means x is equal to minus 2 on 3. Minus 2/3. Okay, fair enough. Now I'm thinking, yeah, that's going to scare you enough to justify it being a 3 marker. So x is minus 2 on 3. And the check is going to be a bit challenging on this one, but we can do it anyway. What do we have? 3. Look at how this works out. 3 times minus 2/3. If I'm going to multiply minus 2/3 by 3, and no, let me just make this clear. I'll just pause. I had to think about it a moment. We're checking in equation 2, okay? So this is an equation 2 check because we did the substitution in equation 1. We don't want to do it again there. What's 3 times minus 2/3? 3 times minus 2/3. Well, 3's are going to cancel out because 3 is the same thing as 3 times 3 on 1. You see, I'll just do this the long way. 3, and I'll do it here. If I have 3 on 1 multiplied by minus 2 on 3, well, you multiply the top numbers. That's your easiest multiplication, giving you minus 6 divided by 3, which will give you minus 2. So we're getting that 3x is minus 2 on either of them. It's minus 2. And then the minus 4y, what do we have? Minus 4 times minus 2. A minus and a minus makes a plus, so that's actually positive 8. So this whole string, what it works out to be, the 3 times minus 2/3 is going to give me minus 2, and then I'm adding 8. And minus 2 plus 8, remember it's the second equation we're working with, minus 2 plus 8 is going to give me 6. Oh yeah, we are right. The answer to the question is indeed x is equal to minus 2/3 and y is equal to minus 2. So you can see, although we didn't have to do any multiplication, what made this question uncomfortable or the challenge was your two values for your value for x and not y, your unknowns. One was a negative number, both were negative, one was a fraction and negative. So the actual answers you were going to get are answers that will make you very uncomfortable. But you have just done a session with me, so you know to expect this stuff. You're not going to freak out because you get a fraction or a decimal. You're going to know that can happen sometimes. And the key thing is you will check. You will check. A lot of people, what's going to happen a lot of times is that you do lots of these questions in some exercise from a textbook, and all the numbers are nice, cushy whole numbers. So as soon as you get one like this, it's like, I'm doing something wrong. Sometimes it has to be wrong. No, this has never happened before. But it's okay. The numbers can be funny. They can be messy. They can be fractions, decimals, negative numbers. Main thing, check. Do that check at the end to make sure what you've done is right. That's the main thing.